Hello everybody. Sorry I couldn't be with you today, but we'll go ahead and do our notes at any rate. Today we're going to be looking at the variability, and this is for skewed distributions, and we are going to be learning about this thing called IQR, which some of you noticed yesterday on your review packet. IQR stands for interquartile range. That's interquartile range. Similar to the range that we calculate before, where we take the maximum, subtract our minimum, only we're looking at in sort of a smaller inside range. We'll talk a little bit more about that in a moment. But please know for now that IQR is short for interquartile range. We're going to be identifying outliers, and in order to do that, we have to do some calculations which involve the IQR. So to find outliers, we're going to apply a formula which uses our interquartile range, the IQR. So here we go then. At this point, when we've been looking at the spread of our data, we've been looking at the range, which is equal to the maximum value minus the minimum value. And when we do that, we get a feel for how spread out the data is, but it doesn't really tell us much more than that. It doesn't tell us what's going on. So if we have skewed data, it's hard to tell where the cluster of most of our data is and where the tail is. So we also look at variability and spread by examining this interquartile range. And to get the interquartile range, we need Q3, the upper quartile, and we need Q1, and we just take the difference between those. So we're taking the difference between the upper quartile and the lower quartile. And that is simply the IQR, or the interquartile range. Here the formula is given to you down here. Now this is something that we use primarily when we have skewed data, or at least it becomes more important when we're looking at skewed data. So keep in mind, this is good for analyzing skewed data. Most of the time we're going to use the Q3 and Q1 values that we get from our calculators. However, please remember, if we have a set of data, and I'm looking at these values here, a 2, a 3, a 4, 5, 6, 7, 8, 9, and then a 45, if I wanted to find the median, or Q2, I just pick the middle number. That's my Q2. If I wanted to do my calculations of Q1 and Q3 by hand, I would take the data, the lower half of my data, this lower half here, so everything left of the median, and I would find the middle value of that. Now the middle here is between my 3 and my 4, so if I average those together, 3 and 4 gives me an average of 3.5. That's my Q1 value. Then if I look at the upper half of my data, everything to the right of the median, and I find my middle values, in this case I have two values that are in the middle, the average of those two would be 8.5, and that's my Q3. So I don't always have to rely on the calculator to give me Q1, Q3. I can find it by hand, but if I'm going to do that, keep in mind your data must be in order least to greatest. So I'm going to write down here, must be arranged from least to greatest. Alright, so let's turn the page then and look at what we've got coming up next. We're going to take some data and we're going to practice finding that IQR, which means all we need is the Q3 value and the Q1 value. Now, because I'm not able to be with you today, I went ahead and put all of these values in this data set into a calculator. And if I did it correctly, then I did my calculations, came up with a mean value of 8.033, but I really don't need this mean value in order to calculate the IQR. What I do need is Q1 and Q3. So my calculator says Q1 is 7 hours and Q3 is 9.5 hours. Don't need the median, don't need anything else to find the interquartile range. I just find the difference between Q3 and Q1, and that's going to be equal to 9.5 minus 7. My units will be hours in this case, and I get 2.5 hours. So my IQR equals 2.5 hours. Alright, now we're also asked here to interpret what this means. Now remember, if I were to arrange my data and even make a box plot, 50% of my data lies in between Q1 and Q3. So what this means in this particular problem, for an IQR of 2.5 hours, the middle 50% of my data values are within an interval of 2.5 hours. Or in other words, 50% of my data is in an interval from 7 to 9.5 hours. And it's that easy to get the IQR. I just need my Q3 and I need Q1. So let's go on now to example number 2. I've got a couple box plots here that are showing ages of children, so I'm assuming that my numbers and the ages down here are in years. And I've got a group 1 and group 2 and summarized with some box plots. First thing I want to look at, which set of data is more spread out. Now remember, when we were looking at spread before, we were looking at the range. So for total spread, I can find the range for group 1 and the range for group 2. And we find the range by taking our maximum value, subtract the minimum. So for group 1, looking at group 1 now, the maximum value is here. If I read it down, looks like my maximum is 13. So I'm going to take a 13 and subtract my minimum value. That's here. Reading down on my scale, that's a 7. So I get a range of 13 minus 7, or 6 years. Group 2, maximum is here. That's a 14 years. And my minimum, same minimum as for group 1, 7 years. Gives me a range, 14 minus 7, gives me a range of 7 years. So which data set is more spread out? The one that has the larger range. So that's the 7-year spread. That means group 2 is more spread out. Let's now take a look at comparing the variability. And to do that, I want to look also at my IQR values. So I want to calculate the IQR for both group 1 and group 2. Now remember, IQR is equal to my Q3 value minus my Q1 value. So if let's say I'm going to change the color of my pen here. For group 1, Q3 is here, and if I read that down, that's an 11. And I'm going to subtract my Q1 value here, reading that down, that's an 8. I get an IQR value of 3. When I look at group 2, my Q3 value looks to be a 13. I'm going to subtract a Q1 of here, that's 10. And I get the same IQR value for group 1 and for group 2. Excuse me. That tells me that both my data sets, group 1 and group 2, have that same IQR. So group 1 and 2, or both groups, have an IQR value equal to 3, which means that, so therefore, the middle 50% of the data is within 3 hours. Now, they're not starting and ending at the same points, but they're all clustered within 3 hours. However, despite the fact that the middle 50% for both groups is within 3 hours, group 2 is still more spread out. So it must have a longer tail than group 1 does, which we can see from the box plots. So group 2 is more spread out, has more variability. And if we were to calculate the standard deviation for each group, we should see that group 2 has a higher standard deviation than group 1 does. All right, let's go ahead and turn our pages then. We're going to page 3 here. And if you look at this data, set A and set B should look familiar to you. Need my pen back here. Should look familiar. We've seen this data before. But what we are going to do now is calculate outliers and figure out if any of our data points are considered outliers. Now remember, to do this, we're going to use a formula which involves our IQR. So if you haven't memorized by now that IQR is Q3 minus Q1, you're going to need to do that very quickly here. Okay, when we have a set of data, sometimes we've got some extreme values. They don't seem to fit in with the rest. Usually that means you've got some very small or very large values that really do not represent the group as a whole. And those values are called outliers. Now if I look at my data set A, we had home prices. I've got 1, 2, 3, 4, 5 different home prices here. You can see there's a difference between the mean and the median, which is pulling our mean to the left of the median. Therefore, our data here is going to have a skew to the left. And if I look at my data set B, I have the mean and the median. I have 1, 2, 3, 4, 5 data points again. The mean is also pulled to the left of the median, which means this data is also skewed left. When you've got any kind of skew in your data, you need to check to see if there's any outliers. I've got a formula for finding outliers. It's detailed for you here in this box, but rather than read that to you, I kind of like to explain it down here a little bit. So I'm going to draw a line here, and I'm going to do some writing here on the right hand side to explain outliers. If you still find yourself confused after this explanation, please read through what's in the box and see if that helps you to make sense out of this. I'm going to start explaining this by first referring back to some of the examples that we did in the past few days where we would find the mean of our data set and we would find how many scores, for instance, or how many data points were within one standard deviation of the mean. So in other words, I'm going to say before today, we might have a problem where we would find intervals, and we might say, for instance, within 1 or 2 standard deviations of the mean. Let's say we had an example that said find an interval within 1 standard deviation of the mean. And what we would do is take our data, find our mean, we would add 1 standard deviation. I'm going to use SD for standard deviation simply because right now I'm not sure if we've got a sample standard deviation or a population standard deviation. So I would add 1 standard deviation to my mean and I would get some number, which would be my sort of upper boundary for my interval. And then I would take the mean and I would subtract 1 standard deviation to get the lower boundary. And then I would look at how many data points were in between my 2 boundaries. So I would count up how many data points were inside my boundaries. So that's something that we did in the past couple days. Now what we're going to be doing here today is figuring out whether or not we have outliers, and it involves finding some more boundaries, only they've got a slightly different name. To find this, we want to figure out if any of our data points are not inside our boundaries, but are outside boundaries. And our boundaries are calculated a little bit differently than finding, for example, 1 or 2 standard deviations from the mean. So here's how we're going to calculate our boundaries. And the name of our upper boundary is going to be called an upper fence. I guess you could kind of think of a fence going around the boundary of your yard. Anything outside is an outlier. So to calculate our upper fence, we are going to find our Q3 value. That's kind of like our mean in finding standard deviations from the mean. We're going to take our Q3 value and we're going to add a value that's multiplied by our IQR. We actually take 1.5, multiply that by the IQR, and that gives us our upper boundary or upper fence. Then to find the lower boundary, which is called the lower fence, we don't use Q3, we use a lower value, we use Q1, and we subtract 1.5 multiplied by the IQR. So those gives us our 2 boundaries. Anything outside our boundaries now is going to be an outlier. So remember, if we're outside these boundaries that we calculate, our upper and lower fence, then those data points are going to be outliers. So let's go back up to our data up here. We've got all of these values listed here, and we are going to figure out whether or not there are any outliers. To do that, I need to figure out what my upper and lower fence are, and to do that, I need the IQR, and I need Q1 and Q3. So I went ahead and put all of this data into my calculator, and I got some Q1 and Q3 values. I'm just going to give those to you here. Everybody should have certainly had enough practice finding these values on the calculators. Q1, I got a value of 14.4. Q3, I got a value of 14.9. And that's taking all of the data above. So, few things I need now. To find my upper boundary, or my upper fence, I need to take Q3 and add whatever 1.5 times my IQR is. Now, I need the IQR, so I'm going to come down and I'm going to calculate that down here. Remember, that's equal to Q3 minus Q1, so that would be 14.9 minus 14.4 gives me an IQR value of 0.5. So back to my upper fence calculations, I'm going to substitute in for Q3 14.9, and I'm going to add to that 1.5 multiplied by my IQR value of 0.5. If I multiply 0.5 times 1.5, I get 0.75. And add that to 14.9, and I get 15.65. This is my upper fence. So if I look at my data, any values that are greater or outside of my 15.65 value, that's going to be an outlier. So I'm going to go up and look at my data. I'm going to look for any values that are higher than 15.65. So just jot that down here. Data that is greater than 15.65 is going to be an outlier. So let's see, I've got a 16.4, that's going to be an outlier, and a 15.9, that's going to be an outlier. 15.1, that's inside my boundary, or inside the fence, the upper fence, so not an outlier. And the rest of the data points are also less than 15.65. So I'm all set with my outliers that are greater than 15.65. Now I need to check my lower fence or my lower boundary. So let's go ahead and do a calculation for the lower fence. Remember, this is Q1 minus 1.5 times the IQR. So I need my Q1 value. We said that was 14.4. And 1.5 multiplied by my IQR of 0.5, that's going to be 0.75 when I multiply it. And then I'm going to subtract that from my 14.4, and I get a value of 13.65. So that is my lower fence or my lower boundary. Any data to the left of that, or any data less than that lower fence, is going to be an outlier. So if I look at my data, I'm looking for anything that is less than 13.65. There's 10.2. That's less. That's going to be an outlier. And then the next highest one is 14.1. That's fine. That's not less than 13.65, so not an outlier. So it looks like for this set of data, I have 3 outliers. And those outliers are, I'll list those here, 10.2, 15.9, and 16.4. And when we do box plots and we have outliers, we do not include those points in our whiskers. So let's go turn the page and look at our next example here. And we'll look at how do we go ahead and create a box plot from our data if we do have some outliers. Now when I look at this data, general observations, let's take a moment and think about what we've got going on here. like we've got some skewed data. It's not symmetric. And it's skewed where our tail is on this. That would be to the left. Which indicates then if there's skew to the left, I may, not necessarily do, but may have outliers left of my cluster of data. Well, let's go ahead and figure out what our outlier boundaries would be, the upper fence and the lower fence, to see if we do have any. So we're going to calculate our 5-number summary. I am going to tell you that I put this data in my calculator to get all of the values, only I'll show you I made a mistake in my data. With this point right here, I entered my data, and instead of entering a 56, well, here, let's see what I did enter. This is my calculations in my calculator. I entered, instead of a 56, I entered 46. So my data is going to be a little bit off here. This should have been a 56. But when I did my calculations using one incorrect data point here, did not affect my minimum or maximum. My minimum is still 42. My maximum was still 89. And actually, my other values did end up remaining the same. Mostly because I do not need the mean calculated for a box plot. If I needed the mean, my mean with the incorrect data point, in other words, with a 46 here instead of a 56, my mean would be off. But it turns out, luckily and fortunately, the rest of the numbers for Q1, the median, and Q3 remain the same. Q1 is 74. Median, or middle number, still 81. Upper quartile, or Q3, still 85. So interquartile range I need, so IQR here, Q3 minus Q1, 85 minus 74, gives me an IQR value of 11. Now I need to find out if there's any outliers, which means I need my upper and lower fence. So here we go, upper fence equal to Q3 plus 1.5 times IQR, which is equal to my Q3 value of 85 plus 1.5 times my IQR of 11. And that's going to give me an upper fence value of 101.5. So I'm going to go look at my data, see if there is any data point that is greater than 101.5. Looking at my data, no data points are greater than 101.5. So no outliers to the right of my data, which makes sense because I really don't have any skew to the right. Let's take a look at the lower fence and see if we have any outliers there. Lower fence is equal to Q1 minus 1.5 times the IQR. So I want Q1. Q1 is 74. I'm going to subtract 1.5 multiplied by my IQR of 11. And I get a lower fence of 57.5. So I go back up to my data and it looks like, oh, I think I've got 2 points that are less than 2 data points less than 57.5. Looks like my data point here at 56 and here at 42. So outliers, 42 and 56. Now I'm going to make a dot plot, and when I make my dot plot, I still need my 5 numbers. However, I cannot include 42 and 56 in my whisker, so it's going to change things a little bit. What I'm going to do for my outliers is put a little star above those points. So 42, there's my little star. 56, there's my little star. And now when I go for my minimum value, which I normally would have be connecting with a whisker, was 42, but I'm not going to connect that with a whisker. I've got to go back to my data and find my next smallest data point. Looks like it's here at 69. That's where I'm going to put a point on my dot plot, and that 69 is going to be the end of my whisker. Then I'm going to continue and put points for Q1. So I need one at 74. I need one at my median of 81. So here at 81, I need 85. And I need 89. Should be here. Somehow I'm going to now connect my bottom two, my upper two, create my box around the middle, and put a vertical line for the median. So I'm just going to put these outliers here now in blue so that everything's in the same color. Here's my new box plot, and it's showing my box and my whiskers and 2 outliers here. Now I want to show you on your calculators, you can have the calculators go ahead and do a box plot for you. So here's how we would do that. You would go to your calculators, enter all your data just like before, and then hit that menu, go back to the screen where you can go ahead and do a plot. So this screen here just shows where I've got my Q1, my Q1 value, my median, my Q3, my max. This min, not a box plot minimum anymore because it's an outlier. So here's what I'm going to do then in order to graph this thing. With my calculator, I'm going to go to my menu button. I'm going to go back to the screen that lets me plot. You guys know how to do that, just like we do for a scatter plot. Only when I hit that menu, so this menu I get by going to the button that lets me do graphs. When I go into that screen, I want to press the menu button, and I get this screen here. I want to highlight plot type and then choose box plot. When I do that, calculator is going to take all my points and it's going to show me the box plot, and it's going to include my 2 outliers here. Notice they are not connected to the whisker. And my next lowest point after my outliers is here. Here's my Q1, my median or Q2, my Q3, and my max. So the calculators will go ahead and do these box plots for you. I think if you take the cursor and hover over any of these points, it'll give you the values of those. So you can experiment with that. But that pretty much takes everything that we need to know, gives it to you for your lesson today. Your homework is going to be using your knowledge now of outliers and how to calculate them, and IQRs, and filling in values and doing some box plots. So you should be able to do these box plots by hand and with the calculators. So if you have time left in the period, you can go ahead and work on some homework. I will see you all tomorrow. Thank you very much for listening. Have a great day, guys. Bye-bye.